Imagine typing a single sentence into a chat window, hitting enter, and watching a fully functioning software feature compile in seconds. At the top layer of the tech stack, productivity is multiplying exponentially without requiring extra human effort. Code generation tools allow small front-end teams to churn out features at a pace that used to require dozens of engineers. Because the friction of writing code is practically gone, the deployment cycle never stops. Front-end developers push an endless, high-speed stream of new applications, features, and updates directly into the pipeline. That infinite output at the top creates an illusion of invincibility. It is easy to assume the systems underneath can automatically scale to handle the load, completely ignoring the hard, physical limits of the infrastructure actually running the code. But drop down from that bright, frictionless app layer into the data platform infrastructure, and you hit a terrifying bottleneck. Down here, the foundation is managed by human engineers. These teams are bound by human scaling limits. They have to manually review, test, and deploy the tidal wave of code crashing down from the AI-powered teams above them. And the AI agents writing that code are highly goal-directed. If an app layer bot hits a roadblock, it will quietly brute force its way around it, sometimes unintentionally altering hidden internal APIs or pinging a database thousands of times to get the job done. A single hallucination, like a bot accidentally flipping a critical feature flag, can take down an entire live production cluster instantly. The hyper-productivity designed to scale the business acts as a friendly fire denial of service attack on the company's own infrastructure. This diagram illustrates the collision. The primitives are completely different depending on your layer. On the left, app AI agents work in isolated environments, failing safely against fake data stubs. On the right, infrastructure changes happen in the wild. A single automated tweak to a Spark cluster must correctly interface with live logging, observability pods, and routing services all at once. You cannot apply a rapid-fire guess-and-check AI methodology to live interconnected infrastructure primitives. If an agent guesses wrong here, the entire system crashes. This mismatch creates a massive knowledge gap. App developers are deploying complex workloads generated entirely by AI, often without understanding how the underlying tech actually works. When that generated code inevitably breaks the live cluster, the front-end developer can't fix it. The entire debugging burden transfers straight down to the platform team running the code. Manual code review simply cannot keep pace with exponential code generation. Human engineers are stuck fighting an unwinnable arms race against their own company's AI bots. The required response is an automated strategy called defense in depth. Infra teams are building specialized bots tasked exclusively with protecting the core. These agents run autonomous code reviews, handle midnight bug triage, and instantly sequester bad workloads before they can spread. You cannot stop an automated threat with human hands. The only way to survive an AI deluge from above is to build an equally automated, highly specialized defense system below. This diagram maps out the target survival state, a tech stack balanced by a multi-agent architecture. You can't rely on a single generic model to do everything. An agent aggressively writing features cannot simultaneously act as a cautious, skeptical reviewer of its own work. Instead, specialized infrastructure agents act as strict gatekeepers. They evaluate incoming code proposals, negotiate with the app layer bots, and validate every change against the platform's safety rules. Stability in an AI-driven stack relies on distinct agents checking and balancing each other's work across every layer. Tech leaders cannot continue managing their infrastructure teams at human speed while letting their app teams accelerate at AI speed. To survive, companies have to hit pause on routine feature requests. Platform engineers need that borrowed time to build out automated defense harnesses and agentic operations protocols. That time must also be spent creating private evaluation suites. Teams need isolated environments to test emerging model capabilities on internal systems safely before unleashing them into the wild. Companies have a stark choice: invest in autonomous infrastructure defense today, or watch foundations collapse under the weight of their own AI-fueled growth.